So we're finishing up our chi-square tests. What we've done, so we can tell our guys at CSI, we went about and had our students collect the data from the student body of our high school. We had a total of 283 students, and we're going to do a couple review questions about using our data here. First of all, what kind of study did we do? What's that? Not the chi-square test, but what kind of study did we? How did we collect our data?
Random survey.
Random survey. Okay.
Supposedly random. Yeah, it's pretty random.
Yeah, I was asking kids. I didn't let all the kids go by. I let some of them escape. I got some of them, pinned them down, wrestled them, beat them up a little bit. Give me your hands! Sorry to distract us. Right. So what we're going to do now is I want you to make a double bar graph that deals with a way to compare the data that you see. I want to keep it as the categories to be. What do you think?
Index and rank.
I'd go male and female, but it would be interesting to see if you could do the different fingers too, if you wanted to. Okay? All right, let's pause that. So this is my bar graph. A couple things that I wish I would have done differently. Personally, I would have changed my scale to be a little bit more. I didn't have to go to 100 on my percentages. I could have gone by the 50s and adjusted it that way, made it a little bit easier to read. One thing we got to include is that I have a key and then label my axes. So this is my proportions. And probably just like a fingers of left hand. Okay. What would we write for our write-up about the what do we see? Anything you would write up? Yeah. Okay. We'd have to include something on the AP exam. You'd have to definitely describe what you see. So you could start with the ring finger. That one's kind of obvious. That we would say that the ring fingers are pretty matched up, right? Okay. So we come into here and say ring fingers are about the same. Then I would say index, the proportion of males had longer proportion of males had longer index fingers. And then the proportion of females had the same length. Okay, so that would include our write-up, so that way we would know what we're talking about, or at least we would be able to fake it. Okay, so what would we write up for our null and alternative hypothesis? So I'm going to put that right here. So let's go ahead and pause it so they're not bored out of their minds again. Okay, so this is what we discussed in class. There is no association between gender and relative finger length of students at IFHS, and our alternative would be that there is an association. Okay, then we're going to go into our conditions. We already started talking about that off camera, so let's just start first of all independent. Okay, students are students are independent. Random. Was it random? We're getting a lot of head shakes, no. Okay. We realized that it was not random because we didn't do anything to make it random. We just asked the people around us. So what kind of survey would it really be then? Convenient. A convenient bias and everything like that. So realistically, this is going to be a no, but we're going to pretend. Okay. Nathan, 10%. So if we have 1,500 students at Idaho Falls High School, what's 10% of 1,500? 150. So the problem is we asked a total of 283. That is
more than 10%.
Okay, so that's more than 10%. So would that one fail for us as well? We would fail on this one too, but we are going to pretend. Okay, but realize that if we ever did this, we would just call it a wash and walk away, correct? Head nods yes. Okay, so we done the 10%. What's the last thing we got to do? Large counts. We got to do large counts, which means that all our expected counts need to be greater than 5. You calculated them all for us already?
Yep.
Okay, what is the, let's go male index?
51.62.
51.62. Ring finger?
77.43.
77.43.
36.95.
36.95.
And the other one, index, 36.38.
36.38.
Ring, 54.57.
What was that one?
54.57. And same, 26.05.
26.05.
05. And fun fact, all those numbers are bigger than 5.
Yeah, fun fact. Okay.
Maybe swing.
All expected counts are larger than 5. Okay. Then we're going to say that we're going to do what kind of test?
Two-way chi-square test.
Okay. Chi-square test.
Of homogeneity.
Wait. Alpha.
What do you want to do for your alpha level?
0.1.
No! Stop saying 0.1. It's 0.05. Thank you. He's wrong.
Okay. I'm going to go ahead and pause it again so I can enter my data into the matrix. Okay. So we got the data, put it into the calculators. Let's unfreeze this so we can. So there's my matrices. Go to my stats, go to my test questions, and then everything looks great. So then I get a chi-square score of 4.27. I get a p-value of 0.118. And then my degrees of freedom was, of course, 2. So if I go back to our degrees, our whole, we would fail to reject. Yep.
I told you we should have done.
Even if you did 0.1, guess what? You still wouldn't work. Okay? So then what do we write up here?
There is not sufficient evidence to reject the null hypothesis.
Okay. So we chalked that one up to be. So we had to do a lot of pretending, right? That we could use the data. It wouldn't always work, but like we said, it got it to it. Okay. Let me pause this.